Hey, good morning, everyone. We'll start our sessions in the next few minutes. We'll wait for more people to join, and then be in a couple of minutes. Let's start the sessions. Good morning, Priyanshi. Let's get started, everyone. It's about 9:40 by the time, usually the time in which we start. So, good morning, everyone. This is our third session, and I'm super glad that you are with us for the past 3 weeks for our starting off with our biology session and the chemistry, and today's session is on physics. Um, so I'm very, very happy that you guys have been with us through this journey, and you guys have been sharing your feedback with us and having active discussions on the WhatsApp community. Um, so today's session would be on physics, like I had mentioned, and the topic is motive force versus force motion. Thanks to Rachna ma'am for coming up with this amazing topic. Rachna ma'am, thank you. And let's see, over the next few slides, looking forward to hopefully you guys will have fun attending the session as much as we did preparing all the content for it. So as usual, um, a few words about Adhyaapan before we get into the session. Adhyaapan is an inclusive ecosystem where um, entrepreneurs, educators, industry experts have a unified vision to kindle curiosity of young budding minds using an application-based pedagogy, a curriculum-focused learning, an interdisciplinary education, and last but not the least, regional language teaching. So, in very simple words, what Adhyapan does is let the students know why they learn what they learn in school, uh, and then we teach them through real life applications on what they learn. And through these real life applications, we bring in industry experts so that students can get to know more about such career opportunities early on in their lives, and then have the career awareness that they need very early on in their lives. We believe that once students start to learn the Adhyaapan way and understand the concepts better, they become more curious, and through these curiosity comes innovativeness and everything else you need to understand the concepts inside out. Once you have this kind of understanding and once you have a career awareness, we believe students can start thinking about more about their careers, the kind of job opportunities they want, the kind of roles that they want, and start to prepare for it very early on in their lives and hopefully find their passion. Um, so with all of this is what Adhyapan was started, and I hope you have been able to see this in our sessions before and all in all the upcoming sessions moving forward. Next slide, Radhika. And before we move, like, can I please request all of you guys to mute your side, please? Thank you, guys. So today's speakers, as usual, we have a academic expert and an industry expert. We have with us Ratika back again. You would have seen Ratika in our biology session, and I love the feedback that you gave about her session. And then we have Ratika back again with us. She is our science educator and content developer. And we are super happy to have super happy to have Ratika with us again, and all the enthusiasm and the energy with which she delivers her sessions. As you guys already know, Ratika is a science teacher with over 7 years of teaching experience. She has her undergraduate and master's degrees in biology, and she's also a gold medalist winning student in her undergraduate during her undergraduate studies. Ratika excels in the experiential learning way of content development, and you guys would have already seen how she delivers. So Ratika, welcome again today for our session today.
Thank you, Arjun. Hi, everyone.
Hey guys. And I have a beautiful opportunity to speak about myself today. My name is Arjun Vijayanarayanan, the founder and CEO of Adhyaapan. I have my background in aerospace engineering. Um, One thing that why Adhyaapan was started was, and I spoke and I mentioned about finding passion early on in your lives. I found my passion in aerospace engineering in my 7th grade, and ever since it has been a wonderful journey. So the thing about Adhyapan is, if you guys can also find your passions through all of these applications and career opportunities that we portray or we show in our sessions. Um, Trust me, there is nothing like finding your passion early on in your life, because all this dedication and hard work and commitment comes naturally because of the passion. So enough about me and all that passion. Let's go ahead with today's session. Katika, over to you.
Hi, welcome, everyone. A very warm welcome. So before I start the session, we definitely have some learning objectives and what I really expect you to do during the session. That would be, please be as participative or even more compared to the sessions that happened earlier, and be curious, be inquisitive as well. Um, the learning objectives for today's session would be, we'll be understanding about types of motion, and I'm sure you might have learned few of them in grade 8 already. Types of forces, what is the connection between motion and force, laws of motion and its application, Bernoulli's principle and its application, magnetic levitation and its prospects, some career prospects as we move alongside, and finally we will have career pathways that can help you to guide your journey in the future. So let's get started. Can I just see how much active you are by saying a hi to me on the chat before I start? Less than 10 seconds. Thank you, Mahima. That was very quick. Ashi, thank you. 5 seconds gone. Thank you, Arun, Khushbu, Raghav, Gauravi, Varshini, lovely, Medhavi, Prashant. I can see you're already active over here. Thank you, Hema Balaji, Samaira. Thank you so much. So let's get started, and please stay like that over on the keyboard because I would love you to be very active now. So a quick recap that you've already seen: force and motion, something that you've already got to know about different types of forces that we really applied during our daily lives: push, pull, gravity force, which is there exerted on the object, friction, magnetism, and acceleration. So this is just a quick recap for you to come back. So now I would request you to be very active on the chat. There are two images: picture 1, which is picture A, and picture B. Please guess the type of motion in picture A and picture B. The time starts now, and you have 10 seconds. A car is moving just like that, and the trees are passing by. Linear motion, beautiful. That is rectilinear motion to be precise, and that is linear because it's moving straight. Arun, Ashi, Mahima, Khushbu, brilliant. So Ashi, just check. Yeah, rotatory is for the second picture. Beautiful. Raghav, just a correction. It's circular. It is looking like it is moving in circle because it is moving through a fixed axis. That's why it is rotational. Yes, Vanisha, lovely. It's a uniform motion. Lovely. So you already know about uniform and non-uniform motion, and also which type of motion that is. So that's great. Yes, Gauravi Sharma, absolutely. So the precise name of these are already told by you. So let's move to the next one. And let's see if you can see that. Yes, Himawali is correct. Over here, this is another form of periodic motion too, but I want to know the name of that periodic motion in picture number C. Beautiful, Ashi. It's very quick. Yes, Vanisha, that is absolutely correct. Samaira, absolutely correct. Oscillatory, that is oscillatory. Khushbu, that is absolutely oscillatory. Lovely. Arun, yes, just go ahead with some of the typos. I know that you were trying to be very quick, but that's fine. It is periodic. And the second one, you can see the planetary motion, and there is something over here. Yeah, it is oscillatory. It is circular, Rashi, beautiful. So nailed it already in the start. Lovely. So motion, there are 4 different motions that we have just seen right now. And yes, we do have broad categories of periodic and non-periodic motion, uniform and non-uniform motion. So you already know about that. That's great, Hema Balaji. So now I want you to think and share. This is something that you would know, and I am just trying to define it. So Dash laws explains the relationship between a physical object and the forces acting upon it. There were some laws that help them to be governed, and let us know what laws are there. It is given in honor to the person who gave it. So could you come up with what is the name of these laws? Yeah, they are laws of motion given by whom? There are laws of motion, absolutely correct. Okay, Ashi, think again. I'm loving it that everybody is trying to participate. At the end, the learning is our understanding. Yes, it is. Beautiful, Mahima. That's exactly who the person is. Sir Isaac Newton, Himawalaji, correct. And that's why it helps us to understand a modern basics of modern day physics. And he's the person who's behind it. So yes, there are 3 laws of Newton. Absolutely, Raghav. Yatika, yes. Varshini, beautiful. So moving forward, yeah, Bhanisha, thank you for sharing that as well. So I would like to ask, what is a net force? Have you ever experienced a net force, especially when you are using that rope and trying to win in the team? Overall, yeah. So there are overall forces that gets experienced by an object. That's the total amount of force. Yes, Himabalaji, direct force acting upon something. And that's the total net force. Not net meaning total and force. We already know there's some push or pull. So that's happening over here. So the net force exerted on this individual was more, but they actually win, the ones on the side. So yes, so then net force is nothing but the total force felt by an object. Absolutely, Varshini. Lovely. I absolutely love your responses. So, can I have an understanding now on what are the types of forces? So, there comes two types of forces. Um, one is balanced, and another is not balanced, unbalanced forces. So, in terms of net force, we understand balanced forces. So, what can you see in the picture? I'm trying to use my finger from the right and from the left on that object, which is the car. Do you think it will move in either direction? Ashi, lovely. No. No displacement. Okay. No. Lovely words. Displacement. Okay. Yes, it will not move. Why? I'm trying to push it from one side, but what I'm trying to do from the other side is to not let it move. So I'm trying to balance through the other side as well. So because of that, what is the net? Absolutely, Ashi, in simple words, the force applied is the same, and that's why there's no net movement, which is no net force acting on that object. So the object will not be able to move. Yes, Mahima, lovely. Forces of action is also applied over here. Yes. But we usually call forces of action as an example of unbalanced forces instead of balanced forces. So what does unbalanced force look like? What do you think unbalanced force would look like? If I have a car and I'm trying to push it from one side, do you think, can I ask everybody to be on mute, please? Thank you. So if I push from one end, so this is my car and I'm pushing from one side, is it unbalanced? Yes, Vanisha. If the force is greater and there is no force which is stopping it to move, unequal force, that's exactly it is called as. So you can see that the car moves to the right if I'm pushing it from the left side. It is going in the direction of the push that I'm doing. So the net force on that object is zero, and because of that, the object will accelerate. So that's very important. So we do know now. Yes, the car moves and it is unbalanced force, absolutely. And as rightly stated by you, there is something that opposes that motion as well. So something that you've just nailed it. Can I get the name again? The ball is moving, and do you think the ball will continue to move forever and it will never stop? Or it is also the force that helps you to walk. What do you think helps the ball to stop and also helps to absolutely, Arun, this is friction, or also called as frictional force. Yatika, absolutely, Ashi. Raghav, lovely. Naima, Marchini, I absolutely love it. And also request other people to Hemabalaji, thank you so much, to be more active as well, so that I know that you're getting it. So that's right. Now, let's see if you know the laws of motion given by Newton, and I'm not telling you what it is. You have to guess which one is it showing. So let's see if you can guess it from the image. So there's an object that is at rest and will continue to remain at rest. Now, until and unless you come over there and try to use that football to play, like you use your foot to give the force, which is an unbalance from one side, there's no stop from the other side coming. An object, which is the football over here, will continue to be in constant speed and direction until you try to put it over there on the net to make it a goal. It will not stop. So what do you think is the Newton's law? Absolutely correct. First law of motion. Just try to connect it over. Yes, it is having, every action has a reaction, but the keywords that I was trying to force over here was that, was trying to, for you to get the understanding was that the ball is at the rest until an external force or an unbalanced force comes in play. It makes it move, and finally it gets stopped because of the net. Yes, Manvi, lovely words that you have used. So it's exactly right. It's Newton's first law of motion, which simply says a body either remains in rest forever or will move with constant velocity until it is acted by an external force or by a force. So yes, absolutely correct, Manvi. So let's see if you can guess the answer for here. Why do you need to wear a seatbelt, especially if you're a giraffe? Imagine if you're a giraffe and traveling like that, and they just comes over here an obstacle, and then you just like exactly like that. So why does it happen? Your body was moving in particular way. Yes, it is first law of motion, absolutely, and the body was trying to be, yes, Ashi. So inertia is what is another word when the body continues to be in the state of rest. yes, friction, because of friction has happened, absolutely. Also, and the obstacle made it to stop abruptly. This is also called as Newton's law of inertia. So the first law is also it also has another name called, yes, absolutely, Mahima. The body continues to be in at rest or in motion until an external force comes and acts upon it. Yes, Arun, right. So great job at this. So, what is the application of first law of motion? Have you ever experienced this? I have. Like when you have your favorite juice or maybe Coke, and suddenly the brake is applied, or maybe the red light goes, and then you're like, "Oh no, it just got spilled." Why do you think that gets happened? Like, why do you think like that is experienced by us? Yes, I have so many yeses that I feel that I'm not alone in feeling that. Yes, there is some force which happened here. The body was trying to be in the same position the car was moving, but abruptly there was a sudden change and the car just stopped, and the a glass that you were having or holding was also experiencing the same thing. And because of sudden break, it did not know what to do, and it just deviated, and that's why the content of the glass just spilled on you. So yes, absolutely, Mahima, that's exactly right. Sudden stop. So what modifications do you think? Like earlier, the cars never used to have any help for making the glasses to be fine. So Pratha, thank you so much. Yes, cup holders, beautiful, and that's exactly how it looks like. If you would have seen, they have cup holders now, which also move around that, but they try not to spill. So they are designed in a specific manner. So lovely. So that's something that happens here. So let's move also to another application. What do you think is happening in this picture? How do you think first law is applied here? Very interesting picture, isn't it? I would love that everybody can go and experience this someday. Yeah, it's gravity, but how is it helping? There's no gravity, correct? There's no gravity, but how do you think first law of motion is applied here? Like the body, what is happening to the body? Yeah, correct. That is absolutely correct. Because if it is moving constantly like that only, because there's nothing to stop, there is no opposing force to oppose that motion. So yes, Ashi, that's absolutely correct, and that's why one of the applications is over here as well. Yes, Gauri, that's absolutely right. Yes, Mehak, I really like now people are participating and doing a great job, and I also love that the atmosphere here is very congenial, so that everybody is participating. So at the end, we'll all learn together. So let's see now another one that you need to guess. Something is happening in these two pictures. Which law of motion do you think it is applied here? The rocket is trying to just move up like that, and two cars, probably in the car racing competition, is trying to just move ahead and doing something like they're speeding up. Okay, second law of motion now. Actually, just think again. It is second law of motion, absolutely correct. Why is that? What is the second law states? There's a small formula of that for second law. Do you know that? And it's applied here directly. Just see. The more something, the more it's trying to speed up and then move forward. So yeah, Manvi, beautiful. So it is the law of mass and acceleration. How is it connected? More speed, yeah. How is it connected? Mass and acceleration, and what is something that is happening here as well? More. So more force will translate into more acceleration, and that's exactly what is happening. So more the force you give, and more is the acceleration experienced here. So the formula of second law of motion also states force is directly proportional to acceleration, and force is equals to mass into acceleration. So you must have heard F is equal to ma. So that's the second law of motion. Great job. Now let's see if the second law of motion here. Absolutely, Mahima. So we'll talk about application of Newton's second law of motion now. Have you seen some of the times this is a sport which is baseball, and it's trying to apply the same law over here? So the ball is being given to the person who's having that baseball bat. So how do you think second law of motion is applied here? We just saw. Yeah, beautiful. The more the force on the ball, the bowler is applying, and it's already there in the ball, and the more faster it is, uh, the longer way, or the more will be the acceleration on the ball. So that's correct. Great. So now guess this one. We use this law to work. I know that you already know frictional force, but there is something more. We walk by pushing forward, and as a result, we also give a backward force, which helps us to move forward. Beautiful. It is third law of motion. How is that? How is that stated? How is this visible from this picture? Yes, it is the force that we are using, backward force and the forward force. But how is it? Yes, absolutely. But what does the third law states? How is it connected with what the third law states? I'm trying to push, like through putting my foot forward, and as a result, the ground also gives the back. Like because of that, we give to the ground a backward force as well. Yes, it is due to the friction, but as a result, what happens? Yes, Pritha, absolutely correct. Every motion has an equal and opposite reaction. And that's exactly what is happening. Because of this, you're able to move ahead. Nailed it. So over here, action is the force on the ground. The reaction is the force of the ground on us, which is the backward force. And both of them are equal and opposite. And that's why it is the third law of motion. And according to Newton's third law, as you just said, for every action, there's an equal and opposite reaction. Lovely. So I hope you've got the third laws till now, the three laws till now, and let's see the application of the third law of motion in daily life. So can you explain what is happening in this picture and how is third law explained? 10 seconds for you to think and connect. We just explained every action has an equal and opposite reaction. Apply each and every bit that you've learned on this picture, and let's see if you can apply it. The person is moving forward. Yes, Seema Balaji. Push on water. Where? In which direction? Is it ahead? Is it back? Is it right? Is it left? Where is it? You're pushing the water where? And because of that, yes, the paddle is pushing the water backward. So the movement of the boat. Yes, absolutely, Pratap. Backward push on water. As a result, an equal opposite reaction. The boat is moving forward. Lovely. That's exactly what I've written. The man pushing the oars in the backward direction, and as a result, the boat moves forward. Lovely. Next one. Let's see if you can guess this. This is pretty interesting, and I hope you would love guessing this. How is that happening? How is that the third law? 10 seconds again. Yeah, it is the thrust. I love the keywords thrust. Okay. Pressure gives a start. Yeah, but what exactly is happening below, and then what is happening? Yes, the fire or it gives the push, and absolutely the force is applied by the rocket down, and then it moves in the opposite direction, backward. Yes, absolutely, backward push is applied from the rocket. Lovely. So over here you can see hot gas is released from below the rocket downwards, and because of that the rocket moves upward in the opposite direction. The last one, let's see, if you are swimmers, you might be using this almost every time you go to swim. How do you think this is the one which is showing third law of motion? Pretty interesting ones that you must have seen in your life, but might not have connected with third law of motion. Yes, Vanisha, correct. Yes, they are giving a backward force. They're pushing the wall which is there, and the backward force is allowing you to move forward. The more the push, so you can see over here that backward force is helping you to move forward. Beautiful. So that's how the swimmer also uses her leg to push the wall to move her forward in the water. Great. Yes, Himabalaji, absolutely correct. Yes, Gauravi. So let's understand what is the connection between force and motion. So we have understood about force. We have also understood about motion. Um, so if there is no force, or if the only forces are perfectly balanced, as we just have seen, the balanced forces, or there's no force, any object would continue to be at rest forever, or will be continuously moving at the same exact speed. So that's what happens if there is no force, or if there is no perfectly balanced force. Yes, Raghav, absolutely correct. But if unbalanced force comes, they changes the speed of an object, and they can change its speed from zero if they're at rest or stationary to more than zero because they are unbalanced. So now I hope you understand what the force and motion would do. So force, if it is balanced, or that which is perfectly balanced, or if there is no force, the body will not move. But the body will move and change its speed if an unbalanced force applies to it. I hope you understand that now. Yes, Mahima absolutely can also accelerate. So having said that, do you have do you have an idea of how an aircraft flies? For that, as you already know, we have an aerospace engineer with us, and I would love if Arjun can come and help us understand how does an aircraft flies. Over to you, Arjun.
Hey, Ratika. So, guys, this has been one of the most, at least for me, one of the most important findings that ever happened. Before the Wright brothers joined in 1903. So we've studied all about force, we've studied all about motion, and let's see how some of those can be applied from a perspective of an aircraft. So if you guys know about this, that's great. Maybe you learned something new today. If you guys don't know about it, let's see how an aircraft flies. So we have four forces that acts on an aircraft usually, right? You have an upward force called lift. You have the downward force that's called gravity, and then the aircraft moves forward, so that's called the thrust, and then the backward force because of the thrust is called the drag. So as you can see, for every forward action there is a backward action, then for every upward action there is a downward action, just like how we were talking about the Newton's third law of motion. So I would like to explain to you guys how the lift of an aircraft is generated, and from an ideal perspective, which means that this cannot be applied in real life, but to understand the basics of how lift is generated, we can look into the Bernoulli's principle, which basically talks about that pressure and velocity are inversely proportional. So the higher the velocity, lower the pressure, lower the velocity, higher the pressure. Right. And I call this an ideal situation because we don't take into consideration friction and all of the other forces that happen on the surface. So even though Bernoulli's principle, is not the correct way in reality, but to understand how an aircraft flies, it's a perfect way to start the understanding. So just because of how an airfoil is shaped, what is an airfoil before we get there? As you see the picture on the right, you have the cross section of the wing, meaning if you look at an aircraft wing um, head on or right in front of you, that's how the shape of the wing is, and so that shape or that cross section is called an airfoil. So we basically study how air flows over this foil, and that's called the airfoil, right? So we have to study how air flows over a wing of an aircraft, and that's where all the magic happens towards how an aircraft flies and how an aircraft is in air for the most part. So coming back to Bernoulli's principle, you have because of the shape of an airfoil, You have the higher velocity of an airflow on the top, and you have the lower velocity of the airflow on the bottom of the airfoil. This means there is low pressure on top of the airfoil and high pressure on the bottom, which is the aircraft moving up because there is high pressure from the bottom. So this difference in pressure is how lift of an aircraft is generated, and this is how the aircraft keeps itself in the air and moves up. What you see here is called a symmetric airfoil, meaning that once you draw a line between it's called the camber line. As you see on the second picture, there is a dotted line from the leading edge to the trailing edge. And if both sides of an airfoil are the same, it's called the symmetric airfoil. And if it's not, it's called cambered airfoil. And so depending on the aircraft and how much lift you want to generate, how fast your aircraft needs to go, people play with the shape of an airfoil, and those are all for talks for another day. Over to you, Radhika. And so I would also like to talk to you guys about knowing this. What can you become? Right, like everything at Adhyaapan, we connect careers to a concept that we had just mentioned. So the person who studies how air flows over a surface, air flows over a wing, air flows over an aircraft, that person is called an aerodynamics engineer or an aerodynamicist. So back in the day, we were studying all of these physically, and with the development of software, we were able to study aerodynamics using software. So the person who studies mathematically and through software how aerodynamics works, how the airfoil works, how air flows over an airfoil, that person is called a computational fluid dynamics engineer. So as you know, fluid is either air or water. In our case, it's air. So this person mathematically studies how air flows over an aircraft, and we understand a lot of dynamics of the aircraft in the air because of these mathematical computations. Whether you want to do it by hand or you want to do it through software, it is a very important area of study. And this used to be my forte as well back in my master's days. This was my specialization. And once the aerodynamicist or the computational fluid dynamics guys tells you that, hey, this airfoil design won't work, we need to shape it in a different way so that we get the desired performance, the airfoil designer basically goes back and then starts to design the aircraft, playing with the camber line, playing with how big the airfoil is, how long the airfoil is, and things like that. And so all of these are interrelated with each other. And so if you want to study how to design an aircraft wing, you can basically become an airfoil designer.
That's lovely to know, Arjun. And we now understand what is the principle behind the airplane flying. And let's move to the next part and compare the aircraft motion with the rocket. So how do you compare both of these motion, Arjun? Like, how are they same or different? And also, please show some light on the words like lift, weight, drag, and thrust. I already know that lift and drag were explained, thrust as well. So maybe with reference to rocket, if that can be done.
Absolutely. So, like I mentioned on the previous slide, there are four forces that acts on pretty much any moving object, right? Like or any air moving object, I must say. So you have these four as constants, right? You have a lift that's making a spacecraft or an aircraft go up. Because of that, you have, of course, you have weight or gravity that's taking the aircraft or spacecraft down. All of these have to move forward, right? So that forward motion is called thrust, and you have a backward motion as a reaction to thrust, which is called the drag. So from an aircraft perspective, of course, if the drag is higher, the aircraft's not going to move forward, or it moves forward very slowly. If the thrust is higher, of course, it's going to go really fast, accelerates as fast as possible. That's what we want. If the lift is higher, which is what we want, it makes sure the aircraft rises. And if weight is higher, of course, there is no lift anymore, and your plane's probably going to be stuck to the ground. Right. The same forces actually act on a rocket as well. Your rocket, the way it's designed, all the fins of the rocket, the black parts you see attached to the bottom of the rocket, those are called rocket fins. Um, all of these components aid a rocket to go up vertically, or go up in an oscillatory motion, or to the side, etc. So for the most part, we see a rocket launch, but then we only see it go up straight. But then if you have ever seen a rocket launch and then you are at that location, right, and then you see through a binocular, maybe um, after a minute, if you are still able to track the rocket, or you would see that on the screen in any kind of TV channel or on YouTube channel, if you're seeing a rocket that way, you also start to see the rocket deviate from a completely vertical path, and bringing up a rotational motion as well. Same thing happens with the aircraft. If the aircraft has to move, we can go to the next slide, Ratika. If the aircraft has to move left or right, it cannot just go it cannot just turn this way or that way, right? Like, because we are all sitting inside, and we will definitely feel that the aircraft is just going left or right. So it has to go in an angle to make sure that we don't feel any kind of discomfort sitting inside the aircraft. So how do we make this work is called an aircraft, this is called the control theory. Basically, whether it's a rocket or an aircraft, there are three axes or around which they move, left or right, up or down, or rotational, right? So just like your X, Y, and Z axis, like you guys study in coordinate geometry, we have similar axes that we study aircraft motion or spacecraft motion or rocket motion, right? So the axis in which the aircraft goes up and down, it's called the pitch axis. The axis with which the aircraft goes left or right, you call that the yaw axis. And the axis around which the aircraft rolls, we call it the roll axis. So when an aircraft has to turn left or right, there is a combination of a roll axis and a yaw axis. And if you guys want to be a pilot, or you guys play, I don't know, flight simulation at your house, or you have drone aircraft, RC aircraft, and you guys have fun with it, you will definitely know that there is always a bit of a roll or a yaw together when an aircraft turns in a specific way. And when the aircraft is about to take off, the pilot completely relies on the pitch axis. And so it's called the takeoff. At cruise level, they make sure the aircraft is at a balanced level, so the pitch goes down. And then at descent, again, the pitch is played around with so that the aircraft comes down. Same thing happens with the rocket as well, where if the rocket goes vertically up, you already know that it's acting at a specific axis, which is the yaw axis. And then if it's deviating from its vertical motion, it has to go just to make sure there is a specific orbit that it has to catch. Then all of those axes, whether it's the roll axis or the yaw axis, coming into play, making sure that both the aircraft or the rocket cannot just deal with linear motion or rectilinear motion. There comes rotational motion as well that comes into play. I hope you guys understood all that, and then we will talk more in detail actually when I go deep into some of these career opportunities. But for now, this is good to go. So knowing these, again, let's see what careers that you can look into. Right. So this is somewhat of an indirect career where inside a rocket or inside a aircraft, because it goes through a lot of turbulence, because it goes through a lot of gust winds and other things, somebody has to design how payloads can be structurally sound and safe inside an aircraft or inside a spacecraft. That kind of an officer who designs all of that and basically governs what kind of payload can go in. A payload can be a satellite, right? That is a payload officer. The second one is a propulsion engineer, as the word sounds, whether it's the aircraft engines or the jet engines or the spacecraft or rocket engines. The propulsion engineer plays a huge role on understanding what kind of fuels to use, what kind of pathway is this aircraft or spacecraft going to take, and design the engine or whether it's a rocket engine or jet engine accordingly. And then at certain points, and I'll talk to you more about this later, there is something, if the aircraft or the rocket goes imbalance, the way we talk to the rocket or the spacecraft to come back into balance is either by giving some kind of propulsion at some point, and I'll talk to you guys more about it later. And that's how a propulsion engineer comes there. And like I just mentioned, there is constant communication between us on the ground or a rocket or an aircraft, right? And spacecraft communicator and aircraft communicator comes into play. And I already spoke to you guys about flight dynamics before, and I'll touch upon this later in detail. Over
That
to you.
was a lovely insight, Arjun. I'm sure that we learned about axes which look like XYZ, and you have learned about pitch, roll, and yaw, and also probably one of the takeaways that the rocket doesn't move straight. It can move straight probably for some time, but it also has to roll something like aeroplane. So it has both translational motion as well as rotational motion. So that is one of the things that I hope everybody should take in forward. I hope I'm right, Arjun, in that. I'm also
Oh,
learning.
yes, absolutely.
Great. So let's move ahead, and you must be able to now identify the force shown in this picture, something that you would have always played with when you were students, when you were children. What is that? It is magnetism. Absolutely. So what force will that be? Correct, Maima. It will be magnetic force. So how do we define what is magnetic force? So we can just see when we bring magnets, and if they have like poles coming together, coming close to each other, what do you think will happen? Like poles coming towards each other, what will happen? You have 5 seconds. I'm reducing the time. Beautiful, Ashi. They will repel. And if I have lovely Gohila, Maima, Varshini, Mehek, yes, they will repel. What if I bring the unlike poles towards each other? What will happen then? They will attract. Beautiful. So you know what? This is something that the magnets can do. They have a magnetic force of attraction or repulsion, depending on which pole do you bring closer. And it happens because of the electrically charged particles, because of their motion. So whenever you bring, there is motion, right? So there are charged motion, there are charged particles inside it. And do you know that we can also make electromagnets, in which usually the material which is not magnetic in nature tend to behave as magnets by applying electricity. And because of that, a magnetic field is generated. So, what is magnetic field? It's nothing but the area around which the magnetism is felt. So, I hope you would have seen that as well when you would be bringing it. Nothing happens when we are putting like this as magnets at a distance like this. Only when in a specified area, the magnets is brought closer, only then the experience of repulsion or attraction is felt by the magnet. I hope you have experienced that already. This is very interesting one to know about. Guess the image over here. Guess the image that is being shown. There is something over here, which like a small, I could say a sheet or a block, which is moving back and forth. And can you see if there is, if that is touching the surface on the chart? Is it touching the surface? oh, electromagnetic field, magnetic moving on iron. Oh, no, it is not touching the surface. So how is it moving? There is something in between like this, and it is moving. Yeah, there is some force. There is something here. And this is something through magnets that we do, absolutely. But this phenomena in which you cannot see, right? It is helping it to move. This is the principle behind levitation. The word is levitation. We'll come back again on that. I'm just stressing on that. But what is it? We have not answered. We'll watch a video for answering that, but you can probably, yeah, I'm loving that you're guessing. Something similar, Gauravi. We are using and exploiting the property of a magnet here. So we'll see what it is, and let's understand better through a video. So I have just explained levitation is a word which you can probably see from here, that there is something invisible. So basically levitation is nothing but it's an action of rising or something that can cause something to rise up. And there is some magical power that you probably can see. There's an upward force which is here and which is making it to move, and it's not coming down due to gravity. So that's the upward force, and that's the meaning of levitation. So let's understand what this image that I just asked you means or is. So this is a video by Professor Eric Lethward, and I'll be showing you some snippets to understand what it is, and also we'll talk about the application of the same. So let's get started. So
permanent magnets are difficult things to understand. In fact, if we're absolutely honest with ourselves, we don't understand them.
You see, either end of a bar magnet will attract a piece of steel. But it doesn't follow that because it's painted red, it's a magnet. Because look, it won't pick up.
So this over here is just showing you how it behaves, a magnet behaves, and does like attract the magnetic objects, but there is a different way in as to how two magnets react. So we've already talked about that, and we'll just show over here again.
That piece of steel, but this one will. So this one's the magnet. But the only real test between two magnets is whether or not, in addition to attracting each other, they will also repel when reversed.
So you just saw a repulsion there, and before that you just saw attraction. So like poles and unlike poles, very, very simple. So what do we do with this? So let's see what happens if we have ring magnets. Ring magnets are the ones which have hollowness in between. And what happens to them? Their North Pole and South Pole are not on sides, they're up and below. So
yes, the whole of one side is a North Pole and the whole of the other is a South. So if we get two of them, we can try and float one over the other. Again, you see, you get the lift.
So you can see that the person is talking, or the professor is talking about a lift, which makes it to stay above it for some time, but because of disbalance, it just falls. And then the person, then the professor will also try to put it on a stand, and let's see how
it's stronger. That's going in roughly the right direction. Now we're getting a lot of clearance. But
so you can see over here that there is something in between which you can't see. It's trying to float in the air. So with this, we tried. So he tries now to make something, and let's see what it is.
So the magnet will attract.
So the magnet is attracting the iron object that is there. And you can see some wires are going. So maybe he's trying to add electricity into it and make something with that. Yes, Mehak.
Either end. Now let's see if we can make it repel by switching on. Current. That end will now attract, and that end repel.
So he just made an electromagnet. That iron was just a magnetic material. It was not a magnet. But because of the turn on of the electricity, and you can see the wires are coiled around it, it behaves as an electromagnet. because of electricity, and the opposite. And when the light pole is brought, yes, because of copper wire, absolutely. And when it is brought towards each other, towards that iron, because of being an electromagnet, it repels. And you can see.
So now we've made an electromagnet. But will it work without the iron core?
So let's see if it works without an iron core.
We'll just use the coil alone. Well, it certainly attracts. And I turn it round, and it just repels. So it is still a magnet.
It is still a magnet. You can see that it's still a magnet. So now this understanding of the creation of electromagnet and this repulsion which is happening, which is being generated, and the lift that is happening between the two objects because of which it is floating. Let's see what he makes of that from here.
The copper to spin, and we call that upward sweeping something a trapping underneath it. When we put a bit of aluminium on, it does push it along, but not very fast.
So he has used.
Let's try a bigger piece.
So he's used aluminium now. So aluminium is not magnetic; it's very weak magnet. But because of electricity, and when you pass the electricity around it, it can make the aluminium to behave as a magnet as well. So, and it's being light. This is being used here, and see what happens with this.
That's better. Bigger still. Better still.
So he's increasing the size of that aluminium strip, and as that gets increased, the way it moves is faster.
See, the bigger you go, and the better it gets. This, of course, we call a linear motor. Now, suppose we increase the current. Would you mind increasing the current, Barry? And we can now hold a sheet of aluminium, which is not only trying to be pushed along, but it's also lifting above the surface.
So earlier ones was not lifted, but as the size is increased and the electricity is also increased, you can see that it's now having an upward force. It is lifted in the air. This principle is what he calls something.
It's much more like what you would expect if you threw a piece of wood into a flowing river. It would float and move along. So this then is the beginnings of a magnetic river. But it hasn't got
Use the term magnetic river.
Thanks. Because if I take my thumb away from here, it'll fall off the side. If I take it too far towards you, it'll fall off the other side. But if only we could stabilize it, then we should have some.
So by using that,
one row of
he also made several loops of those wires which you just saw, and made such a setup to make this work and allow this levitation that we talked about to be more visible.
Coils, and the other one on the other side. But this time the coils have been divided up into groups so that we can.
You can see how it moves. Like there's no touch, and it just moves so quickly. And now he brings something that you probably could see. And
Now we're going to dress up this piece of aluminium to look like a passenger carrying vehicle. The scale of this operation is such that this will now travel at the equivalent full-scale speed of 250 miles an hour. And Barry, if you'll start this one, I'll have to go and catch it because this is rather expensive.
so now let's see what happens with this one. So did you see that it just moved so fast, and there was no touch between the ground and between the vehicle, that object which was made to. So coming back to the question, what do you think now this image shows? Yes, Varshini, that's absolutely right. There was a term which was given over there when he was trying. It behaves as something. 5 seconds. Absolutely, Varshini. It is magnetic river. The name of this was first given as magnetic river.
Permanent magnets are difficult things.
So let's move to the next slide and understand something that is applied over here as well. Can you guess what is this image talking about? Yeah, Mahima, absolutely correct. Wow, we will talk about Hyperloop soon. Yeah, it was the first way of using magnetic river and coming up to this point of crafting this, which looks like train. So what do you think this is called as? 5 seconds before I reveal it. Is used to for traveling in many European countries. It is magnetic train, correct. So the name of this magnetic train is maglev. And I just explained to you the understanding of levitation. It's the upward force or something that can carry and get lifted up. And this is floating vehicle. We talked about the principle as well and how it transports. It's either through electromagnetic attraction or repulsion. So we'll study about it a little over how magnetic levitation happens. This is a cute picture of how the train is moving without the wheels in it and is displaying the same thing. So you can just simply see how levitation happens. Levitation is simply how it can be in the air like this and exert an upward force and yet not come down because of gravity. So this happens because of repulsion used by the magnet. So you can see how it is here, not repelling, so it cannot go down. And that's why it pushes the train upward. Propulsion, which means movement, how will that move? You can see on the sides, there is alternative south, north, south, north. And on the train, there is also north, south, but at a distance. So what happens is like poles repel and push the train forward, whereas the opposite poles over here attract and pull the train forward. That's how it remains in the track and move and achieve greater speeds. So possible careers that one can have if they know about this would be electromagnetic design engineer, how to design electromagnets and make it work as something like this. Electrical engineer, it involves electricity as well, and how you can use that to come up with such great technologies. Also mechanical engineer. So applications of magnetic levitations in future, and this is something that you would love to know. You know that we can have a floating city if we use magnetic levitation as one of the principles, and the floating city would look like this. The city floating in the air because of magnetic levitation. Space launch systems. So even the space launch that we do with the rockets, it can also attain a lot of high speed because of magnetic levitation. Also, there's the third one over here, which says Skytran pods. You can see that they're small pods in which people can move from one place to another. Apart from that, hyperloops. I think one of you said hyperloops, and that's exactly what is one of the applications of magnetic levitation. This is a loop, very fine, very narrow loop in which people can travel, and it travels at a very high speed. The principle behind it is magnetic levitation. And you know that Team Avishkar, one of the India's team who are a group of students from IIT Madras, they actually participated in an international Hyperloop competition. And it was the only Asian team who actually went till finale. And you can see that Elon Musk is in the picture of SpaceX Hyperloop competition. And they went, I think, in 2019. They also won most scalable pod design award by Zilow's Hyperloop, and were also in global top 5 in mechanical, propulsion, and levitation award. So other applications include 3D culture, studying weightlessness, magnetic bearings. And having said that, let's see how much do you remember. So let's have a quick quiz. Can I have the link of the quiz on the chat? 1 second. So I would love if the link can be posted on the chat, and it is posted by Priya. Please join in, and we'll start in 10 seconds. Let me see how many people have already joined. You just have to click the link. And there is one person, Samaira, Mehak, Balaji, Arun. That's lovely. We have last 5 seconds. Please, you guys are so quick. Great. Mohammed, Prashant, Mahima, thank you. Varshini, we'll start in 4, 3, 2, 1, and go. So on the screen in 3, 2, 1, go. If you're traveling in a car and suddenly the speed breaker comes, your body tends to move forward. Which law of motion is right here? Think before you answer, okay? Great, all are done before time. That's so lovely. Let's see the scoreboard. Samira, well tried. Arun, you are nailing it, followed by Ashi. And the correct answer is Newton's first law. Please revisit second law and the third one. It can be either of those if you think, but the question was pretty specific. Let's move to the next question. 3, 2, 1. Dash is an example of oscillatory motion. From the given option, which one do you think is an oscillatory motion? Please think about it before you answer. Oh, so quick. Okay, let's see the leaderboard. Arun, you've nailed it again, Ashi, and then Varshini. The answer is a swing. Just imagine for a ball rolling down the rolling down the ground, it would be just like that. It could be taking curves, but it would not be oscillatory motion, which is a to and fro motion. Next question, over on your screens now. Dash force acts on a moving football and helps it stop for some time. Helps it to stop after some time. All of you should have this as correct answer. I don't think any stopping in 10 seconds. Time's up. The leaderboard says Arun. Great, Ashi. So frictional force is the correct answer. Just think about none of the above and magnetic force. Frictional force is the one which helps the football to stop after some time. So the last question, over on your screen. According to the Bernoulli's principle, dash helps the airfoil, that is wings of the airplane, from below to be different. Arjun specifically talked about it, and I hope you remember that. Okay, let's see the answer. Actually, okay, Varshini nailed it. So it is high pressure from below. So many people got confused about that. High pressure from below, that's why it is not going down. High pressure from below. So I hope you get it now. Let's move back to the session. Okay, so a quick question for you to tell me after the quiz. So how can a skydiver jump from the edge of a space without burning up, but satellite will burn up on re-entry? Something like this, what you can see in the picture. And there's a person over here in the picture over here who's jumping from a good height and is not burning. How is that possible? Any answers on the chat? You have 5 seconds. Let's see if you can guess.
I guess because the astronaut or the skydiver is not exactly going down from space. He's actually in the last layer of atmosphere.
Whoa, Prashant, and I love that you couldn't control, but to share it verbally, that's Lovely. Let's see that. So having said that, I want you to tell me, do you know the person named Felix Baumgartner on the chat? If anyone knows about this person called as Felix Baumgartner.
But it was about Red Bull something challenge.
Oh, what was the challenge about?
He created a world record
Or in what? I love it.
for jumping, highest jumping from the space.
Great.
Highest
And
jump.
what was the distance? What was the distance? Do you know what is the distance? What was the distance? All of the statements that you made are absolutely correct, but I would love to know what was the distance. And it's called supersonic free fall for a reason. What do you mean by supersonic free fall? Free fall, you know that you don't feel gravity, like you don't feel your weight. And
Supersonic means free fall in just high level.
correct, correct. So basically, you feel like floating in this space, but you're not in this space, and then you pick up speed so fast after some time that you do not feel even the air around you because that's too thin. Okay, Ashi. So let's watch this small video. So the distance that he jumped from was astonishing and surprising. It was 38,969 meters, or if I give it in feet, it will be around 1,28,000 approximately. So that's how much distance in feet it was before he took a jump. So let's see. Yeah, Mahima. So let's see a short video about it.
It's still climbing and it'll start be moving here in a little bit. Let's get a little bit. Release.
If you're scared, walk away, 'cause there's no need to feel ashamed. Yeah, we all feel the same. Whoa, where's your passion? Where's your fight
All right, now the whole road is working now. I'm going over.
Jumper away. Speed 725. You're showing Felix in a stable descent. And Felix is back for.
So he jumped from the stratosphere, and this happened on 14th of October 2012, and he landed in New Mexico in US. I hope it was a nice revisit for all of you. I think you guessed it right. So I'll connect now something that you've already seen in your pre-reading sheet about Mars orbiter mission. I would like to connect quickly with how it connects with motion. So you could see over here that this spacecraft, when you see the first part, the spacecraft is injected into an elliptical park orbit. Orbit is the path around which it revolves. So you can see that there are many elliptical path orbits over here, and with 6 main engine burns. So after the 6 main engine got burned, the spacecraft is finally gradually maneuvered with a hyperbolic trajectory. You can see it from here, and finally moves to the Mars orbit insertion. It only happens when it moves out of the Earth's sphere of influence, because if it doesn't exit that, it will still be again back in the Earth's atmosphere, or around the Earth where the gravity is felt. So it has to leave the Earth's sphere of influence to do that. And also, this mission was possible. It was also important in one way that this happened with least amount of fuel, and that was the challenge. And if you know that for the force creation, you need fuel to make it move, right? So with minimum amount of fuel, this happened. And the particular orbit around which it happened was also called as Hoffman transfer orbit. This is the specific orbit through which the this orbiter mission, the spacecraft, finally went to. So I hope you understand how this is relevant, and this was one of the links that I'd already given by ISRO. So something for you to ponder. Do you know how fast we should throw a ball that it doesn't come back to Earth? I'm just leaving you with this question. Maybe this you can understand and read about it. And I also have another question for you. For motion versus motive force. So we've already seen that force causes motion. Can you give me a yes or a no? And probably an understanding of how force causes motion? We just saw force causing motion. Maybe this picture can help. I'm applying something on the ball and trying to deliver it. So what am I doing? 5 seconds. 4. Yeah, we're applying force. The ball is moving down. So force up, and because of force, the motion is happening and the ball is moving. What about motion and force, which is motive force? That's the topic. How is that happening? There is something happening to the glass when this object comes from that speed or that motion. So with this image, you can see that because of the motion of this object, it exerts the force on the glass and makes it break. So it is not always that force always causes motion. Even the opposite is true. Motion can yes, Mahima, absolutely. Motion can also cause force. So this is very important for all of you to understand. So let's recap some of the terms. Velocity is something that we talked about, and is nothing but the rate of change of position in respect to time. It also gives direction. Arjun also talked about an angle that the aircraft or the rocket moves. So that's the orbital velocity. So that is also angular velocity, will just come in a bit. So the orbital velocity, which we just saw in the MOM, the Mars orbital mission also, it is sufficient velocity to make the satellite or natural or artificial satellite to remain in orbit. The escape velocity is the minimum velocity which an object has to travel to break free any planets or moon's gravitational force. Angular velocity was the velocity which happens at an angle, and because of which an object rotates or revolves about an axis. We also talked about acceleration, which is nothing but rate of change of velocity, and pressure is nothing but is the measure of how much force is acting upon an area. So pressure is nothing but force by the area. So quickly, one thing that I would love if you can probably do it at home. We have talked about Newton's law so many times. So I'm giving you another interesting activity for which you only need two things: water that you would have and corn flour. And you can see and create your own fluid which does not obey Newton's law. So with this, and the link for this video will be shared with you towards the end. With this, I'll just come up with new terms learned that you can have a glance of Bernoulli's principle, translation and rotational motion, balanced and unbalanced forces, net force, velocity, orbital velocity, angular velocity, acceleration, thrust, drag, lift, weight, magnetic levitation, and Newton's law of motion, along with inertia. Yes, Varshini, that's absolutely right. So quickly, the learning summary. We talked about types of motion. We talked about types of force. We also talked about laws of motion. We talked about the application, laws of motion. We talked about how rocket and airplane flights are compared. We also talked about magnetic levitation and its future prospects. We also talked about the connection between force and motion. And we talked about the connection between force and pressure, Bernoulli's principle. And finally, we talked about Mars orbital mission as well, with some of the concepts of motion. All right, so some of the career prospects that we've already talked about and Arjun has talked about it in detail. So I would like Arjun to come back again. Welcome, Arjun. And I would love you to connect now. Can you hear me? Sorry.
Hey, Ratika.
Hey, Arjun. So over to you now. So how? So I would love you to talk about aerospace industry in general, and also would love to know what job roles are there if one wants to become an aerospace engineer like you.
Sure. Before I get there, guys, I know that we are an hour and a half already into the session. Can you guys have like say 20 more minutes given to us and then we'll complete the session? We apologize for that.
You will get it.
Can you guys let me know? Can we keep proceeding? Do we have 20 more minutes? We'll finish the session by then, and then go forward. Thanks, Mahimna.
Arjun, can you see? Is it
Yeah, I can click. I'll control it. Thank you, Suhair. Thank you, Varshini. Okay. So there is always a question about what aerospace industry is, right? People talk about rockets, spacecraft, aircraft, and things like that. So before I get into anywhere, I would like to first define or talk to you guys what aerospace industry is, right? So you have the aeronautical industry, all the Boeings and the Airbuses of the world, which probably the commercial aircraft that you guys fly in, and then Asika, can you click on the slide? I'm not sure what is going on.
No worries.
So, and then the space industry, where we talk about rocket launches, all kinds of NASA companies like SpaceX and things like that, which belong. And Ratika, please click. We have the space industry, which again, our own ISRO, Bellatrix Aerospace, Agnikul Aerospace, all budding aerospace companies coming up in India. And then together, this makes the aerospace industry. So you have the aeronautical industry with aircraft, and then you have the space industry. Please click. And then you have the space industry together forming the aerospace industry. So this slide also gives you some understanding of the of some really, really good companies that you guys can work at within India, outside of India, and making so much of advancements possible in the aerospace industry. Next slide, Ratika. So I'll keep saying one-on-one, and then let's click by giving one picture at each time. So guys, I want to just, before I get into it, just some quiz for you guys, just to see how familiar you are with all the advancements in the aerospace industry. First click. How many of you guys know what this is, what this picture is talking about? This was unbelievable when it happened first time. But when it did happen, this was crazy that it was actually a reality versus something that was talked upon on some kind of a TV show before. Yes, Mahimna, that's awesome. This is SpaceX rocket boosters landing back at Earth. I was fortunate enough to see this at night, and this was really something like a Star Wars movie when I first saw it. Something coming from space back into the Earth, and it was an amazing, amazing miracle. Yes, Mahimna, that's exactly what it was. Second click, please. Many of you guys can tell me what this GIF is showing. That's not Mars rover, Mahimna. Think again. This is India's pride. Yes, it is a rover, Arun. Yes, it is the moon. It did not successfully happen, but then this was Chandrayaan's rover exactly. Um, Hopefully, in the soon coming future, ISRO will make this happen a reality. Next slide, Ratika. Next click. Sorry. This is like a few decades before now. How many of you guys can tell me what that is? To everything modern rocketry, this showed the way basically on how things can be compartmentally designed. How many of you guys can tell me what this new GIF is? Atika? Can go one click back, Ritika, it will be confusing.
Sorry.
Any takers for what that is? So this was called the Space Shuttle mission. First ever time there were like separate parts of a rocket, and then you had an aircraft that was attached to a rocket. And first ever time there was like components of rockets being divided into separate components and making sure still a great rocket flight happens. And this was the basis for International Space Station being active and for all of these years. One thing that I actually witnessed the last space shuttle mission. I think this was back in 2012. It was an emotional moment for all of us. Luckily, where I studied my master's, it was just a couple of hours away from Kennedy Space Center. So uh, every rocket launch that ever happened there's no way that I was going to miss any of it. And this was back in 2012. It was an emotional moment when the last space shuttle mission happened. Next slide, Ratika. Or next, yeah. What do you guys think this one is? Any takers on the chat box? Yes, Mamna, this is the Mars rover. So this was the Perseverance rover. And one thing that I want to tell you guys about, even though, of course, the design and all the operation and everything was being done at NASA, the name Perseverance, or for the matter, all of the Mars rovers that NASA has launched and made operational so far, all of the names have come from students like you. Eighth grade students, ninth grade students, seventh grade students. So I would suggest that you guys take a look at NASA's website. Every time or a few years before every rover that has been planned, they set out a competition where kids all over the globe can actually put in their name choices, and the names, all of these names, whether it was Perseverance, Curiosity, Ingenuity, everything has come from students like yourself. Next slide, Ratika. So the question that was asked was the job roles within the aerospace industry. And so there's like 4 domains within the industry that usually have all the jobs that are associated within the industry. And one of the domain that I'll probably touch upon today is the engineering domain. But please make sure that if you guys go to your 11th grade and 12th grade, you can still study commerce or humanities or anything of your passion and still be in the aerospace industry. That you don't have to be an engineer to be in the aerospace industry. That's one thing that I want to put across, whether you study commerce or humanities, you guys have well-paying job roles within the industry. But today I will touch upon engineering, aerospace engineering, as the job options that we will see. So I've just shown you guys a few options with electrical engineering, electronic engineering, aerodynamics engineering, like I had spoken to you about, control dynamics, thermal propulsion engineering, chemical certification and tooling. Next slide, Ratika. So I'll just take some time in explaining to you guys or showing you guys what some of these job roles are. Next slide, Ratika.
Thank you, Arjun, for sharing about the job roles.
Yep. So the one thing that I already discussed in detail before was the aerodynamics design analysis engineer, guys. Like I spoke to you about, everything that was manually done at wind tunnels before is all done being software these days. And like you can see, so this is showing velocity, right? So all the lines that you are seeing is actually air, and how air reacts when it touches the wings of an aircraft. Like you can see, the air which is green, when it touches the leading edge of the aircraft, it becomes red, meaning that velocity of air increases on the top of an airfoil. And you don't see the bottom here, but then you will see that the velocity is not as red, or could be a heavier green in the bottom, showing you like what we saw on the Bernoulli principle slide. Next click, Ratika. How many of you guys know that a wing of an aircraft can actually flex that much? This is like a scary sight to see. If you ever fly inside an aircraft and if you guys see wings flexing so much, but all the worst possible load cases that can happen, we actually test for 20 times that, 30 times that sometimes, depending on the company that you're working for, just to make sure that this never happens and the wing never breaks. So we call it the wing load test, and we keep flexing the wings. We put like as much as load as possible till the point where the wing actually breaks. You guys can go to YouTube and actually test or actually look at some wing loading videos. And it's like pretty cool to see. And it's like crazy where you put in millions of dollars to make this work and actually break it. But that's the amount of safety is being set into all the aircraft just to make sure human lives are safe. And the engineer that studies all of this, designs the structure and analyzes the structure, is called the structural design and analysis engineer. Next slide, Ratika. First click. So we were talking about engines before, and we were talking about thrust, right? So the person who studies engines and sees how hot an engine can get, the materials that have to be used, is the heat propagating in a way that is not supposed to be propagating? Is the aircraft structure being impacted because of the heat? All of that is being studied by a propulsion and thermal analysis engineer. It's a very, very, very fascinating role. So any kind of engines, whether you have the jet engines like aircraft or rocket engines, any of these engines possible, the thermal and propulsion analysis engineer studies all of those and make sure that the engine works safely and within the parameters that we have mentioned. And the last slide, or the last job role that I would want to discuss with you guys, is the dynamics and control engineer. Like I spoke to you guys about the axis of an aircraft, right? The pitch, the yaw, the roll axis. Just to take an example, this is a satellite which is in space. The satellite has a few parts, and the few parts will have to be facing certain directions at all times. You have solar panels that power up the satellite. The solar panel will have to face the sun always. You have antennas that has to face the ground so that communication between ground and satellite happens constantly. So even if the satellite moves away from this position because of forces or because of imbalances, the programmer or the engineer that talks to the satellite, making sure the attitude of the satellite, we call it the attitude, making sure the attitude of the satellite is always balanced and as planned, is the dynamics and control engineer. They make sure that the satellite faces this way always. And the same thing with an aircraft or a spacecraft, how autopilots work, etc. All of those are being defined and programmed by the dynamics and control engineers.
These were really super cool aerospace rules, Arjun. I'm sure they were inspiring. So moving ahead, we would love to know about your current role. What exactly do you do?
So I currently work as a aircraft certification and integration engineer. And what I do currently is with satellite communication devices. If you guys have seen, dish antennas in your houses through which your TV works, or if you've seen like modems and routers in your houses for surfing or Wi-Fi connections, basically, um, that's basically what I do for aircraft. The same kind of devices are on the aircraft. As you can see, you have this. Rachika, can you have that laser pointer on there, right there? You see this black thing underneath this housing that these two technicians are trying to place on. That's the aircraft satcom antenna for like aircraft like the Boeing and the Airbuses kind of an aircraft. So that's the antenna which talks to the satellite, as you can see in the picture on your left. And we talk to the ground station, just like how your dish antenna communication works. So whether you say that you want to stream Netflix on the aircraft, or whether you want to see YouTube on the aircraft, everything is possible because of satellite communications. And I currently work on designing it, making sure they are installed on the aircraft properly. And I work with the Federal Aviation Administration, the FAA, making sure that this can be certified. And currently, I work at this company called Viasat, where we launch our own satellites and we provide internet connections for aircraft, for spacecraft, for yachts, anything that moves basically, or even your houses. We make sure internet is possible. And that's what I do currently.
That was great to know. I'm sure that you must have accomplished so many things in your past as well. So would love to see some of the snippets. But before that, could you please elaborate on this question?
Sure. Since we were talking about satellites, can you guys put on the chat box how many satellites are orbiting the Earth at this instant? Active satellites, dead satellites, decommissioned satellites, whatever. Type up your numbers on the chat box on how many satellites do you think are orbiting the Earth at this instant. 10 seconds, guys. We got to keep moving here.
7,000, Maimna. Okay.
That's a good guess, Maimna.
1,000 plus, Ashvi. Okay.
Ashi, that's great. Let's click on the link. Ratika, I shared the link with you.
2,000 plus is what Varshini is saying.
1,500.
Let's see how close all of you are to the real one.
So you guys can play around with this. Just type in stuff in space in your own free time. But that's the amount of satellites that at this instant that are actually, Ratika, can you zoom out? That are actually around orbiting the Earth at this point. You have satellites in all kinds of orbits. And then if Ratika, can you zoom in closely? There you go. You see how infested Earth is with all these satellites that are being launched day in and day out by all kinds of companies. And so this is one thing that you guys have maybe can study to become how to make sure you guys can clean up space debris. Right? Space junk is a real thing. It's becoming problematic. And all the next generation kinds of aircraft companies or spacecraft companies are actually working on this. So this is something that you guys can actually study and see if you can save the Earth from all this infestation happening because of satellites. And so the correct answer is somewhere around the 6,000 mark, or the amount of satellites that are orbiting the Earth right now. So, Mahimna, that was a good guess. You were the closest amongst everyone there.
Great. So my question, I'll repeat my question again. So there would be many accomplishments that you would have done in your past. So what were they, and could you enlighten us with those?
Sure. So because I am into testing the aircraft a lot, aircraft certification, I get to fly around within the US, outside of the US, over the Pacific Ocean, over the Atlantic Ocean, wherever it is that we have to fly to test our communication systems or our radio systems or the aircraft interiors. So one thing that is usually fun for me to do is to go to work and then I take off along with the pilots to make sure that our systems are working properly, whether it's a charter flight or whether it's like VVIP aircraft. As long as we have our systems in, whether in my current company or previous companies that I've worked for, aircraft flight tests are some things that I usually really enjoy to do.
That's great.
I don't fly an aircraft, Mahimna. I wish. I'm actually saving up some money to become a pilot. So hopefully your question will actually motivate me to save more and get to being a pilot. So some other things that I have worked before are VVIP aircraft interiors, which usually, are crazy when I talk about or think about how luxurious these interiors of aircrafts are. So these are both like aircraft that we worked on for kings of Saudi Arabia and a few kings in Dubai. This looks like a 7-star hotel, but this is actually interior of a Boeing aircraft. And whether it is they want a jacuzzi inside an aircraft, a shower inside an aircraft, a library, aquarium, whatever it is that these kings or all these super rich people want on an aircraft, we design them and make sure these are all certifiable. And these are some of the things that are usually really fun to work on, just because of how luxurious these interiors are in. And then when you do flight test these or get an opportunity to go into these aircraft, it's just it's a beautiful feeling. The second most thing that I'm most proud of, the next one will come, the following slide. The second most thing is I got an opportunity to work on Prime Minister Modi's aircraft that just got delivered, I think last year or 2 years before, was the Air India one. This was very interesting to see how secure communication systems work. Because this is for the Prime Minister. There were all kinds of trainings that happened, security clearances that had to be received, secret trainings that had to happen just to make sure that we can design communication systems, interiors, everything that goes on a Prime Minister's aircraft. And this was such a wonderful experience that I got to be a part of designing all of these systems inside the aircraft.
Oh, we are really proud that you are a part of this, and these were your accomplishments so far. Moving forward.
This one was I'm the most proud of this, just because this was history when this was launched through a organization called Space Kids India in Chennai. We launched at that time, this was in 2017, the world's smallest and lightest satellite ever to be launched at that point. I helped put together the propulsion system for this aircraft, and we launched it through the NASA Orion sounding rocket program. And at that time, this was history being created by actually students like yourself who actually performed, who actually designed, came up with the idea, made sure that this was a success. One thing for you guys, if you guys like satellite launching and you want to launch your satellites on NASA, look into this sounding rocket program by NASA, and you guys can sign up for it, design your own satellites and send it to them for launches. We have our own Agnikul aerospace coming upon right now, maybe in a year or two that will be operational, and you guys can start launching your own satellites through an Indian rocket. For the first ever time, hopefully in a couple of years, Agnikul will be operational completely.
That must have been an amazing journey for
It
you.
was.
Great. So let's have a fun experience yet again. So please be ready with another very short quiz to understand how much you've learned. So please join through the link given on the chat. Can I have everybody on mute, please? Thank you. Kindly join the link given. Right now, I cannot see. Sorry. We'll start in 10 seconds. 9, 8, 7, 6, 5. Already 6 people have joined. 4, 3, 2, 1, and go. Please get started now. First question, that works on the principle of magnetism. What's that? All of you are done before time. That's lovely. Let's see final answer. And let's see. Actually, that's lovely. We're topping the charts. So it is maglev, floating city, Skytrain pods, all the 3. So the answer is all of the above. Great job. Let's move to the next one. Now, in 3, 2, 1, go. Dash forms the basis of airplane flight. What is the basis of airplane flight? Actually talked about it. Last 10 seconds. Time's up. All done. So let's see on the leaderboard. Ashi, great job. Arun, Mohammed, amazing. So the answer is Bernoulli's principle. Lovely to see everybody answered correctly. Great job. Okay, so the next question. 3, 2, 1, go. Which Newton's law is applied when a batsman hits a cricket ball bowled by the bowler? I've heard that by that as well. Next 5 seconds. Time's up. So the viewer board shows sorry about that. The internet is a little slow. It asked me to refresh. So the answer, okay, so mixed answers. It is Newton's second law, absolutely. And yes, you can explain it through Newton's third law as well, if you can. But precisely, it would be Newton's second law. So thank you for participating and over here. So having understood your journey, how can we understand and know how can we become an aerospace engineer? If you can show some light and guide us, Arjun, how to achieve a career as interesting and as amazing as this. What would be some of the takeaways for a student to help build them.
So we can get started with, what courses you can take in your 11th and 12th, and then go on from there. One thing that I wanted to again stress on is you can still do biology, take biology or humanities or commerce, and still be in the industry. But again, I just wanted to talk about aerospace engineering. And so for this, can take computer science in your 11th and 12th, or if your school has engineering drawing, these are two courses that you can, or groups that you can take in your 11th and 12th. And in your undergrad, the most common thing would be to do an aerospace engineering or an aeronautical engineering undergrad, depending on the country that you are in. Because India is predominantly aeronautical engineering. And then from there, you go on to do your master's in aerospace and or aeronautical industry or engineering. Doing a PhD is very optional. If you guys want to be a professor or be into academia or do a lot of research, again, for a lab or a university, you guys can think about doing PhD. But if not, having a master's is still good enough for you to get or land amazing job opportunities in the industry.
Great. So what colleges can we be going to get where we want, and what universities do offer such roles?
Sure. There are a few universities that I have listed here. The big ones are, of course, the IITs, especially Kanpur and Madras, the Manipal Institute of Technology, Madras Institute of Technology, and UPES, University of Petroleum and Energy Studies. These are really, really good universities that you can look for both undergraduate and masters. The Indian Institute of Space Science and Technology in Kerala, I believe, I don't know if they have masters right now, but they used to be only a PhD offering university. One thing great about it was you have a direct connection between IAST and ISRO. So predominantly everyone who graduates from there starts to work for ISRO or starts to work for internship opportunities and a lot of in-job trainings at ISRO. So these are some universities that you guys can look into, for your undergraduate, and all those entrance examinations that you have to clear to get into all of these. If you want to do, if you want to know more about it, these are some of the college links that you can use. Maybe Ratika, later we can just fill this up, or I can share all these college links with you guys on the WhatsApp community, so you can look for more about these colleges and other areas of interest for you guys.
Sure. I think the entire session that you took was pretty interesting. So we would love to know what is the future of aerospace engineering, and also what are the skill sets that you think would be really important to have to be in it and to sustain that.
So the next generation is all about autonomous aircraft, drones, huge drones, all these autonomous aircraft, basically zero emission aircraft, electric aircraft, hydrogen propelled aircraft, and things like that. So the good part is we are moving towards electricity and green revolution, making sure that we don't impact the atmosphere in a negative way by using jet fuels and traditional aircraft fuels, all the noise pollution that aircraft generates, and which actually affects not only us but the birds and all the living creatures on the aircraft. So the great part is we are learning a lot from nature, and using those learnings into designing quieter aircraft, cleaner aircraft with low carbon footprint, and making sure we have a responsible aircraft industry moving towards the future. So these things these things are some things that I would like for you guys, because you guys still have, what about 4 + 4, 8 years or 10 years, right, before you get into working. So make sure that you guys are attuned with these next generation kind of aircraft, because those are going to be your job opportunities when you are about to get into the job industry. So all the traditional principles of the aircraft and everything stays the same, because it's physics and mathematics, they don't change. But how it is being used and all the innovations that's happening, you guys have to be updated with that, because that's the future. And when you guys get into the job force, the future will be present. And so please make sure you guys upskill yourself with what is required and taking all the courses accordingly for the future. So that's a good segue into what Ratika asked about skills that are needed. Of course, you're going to require a lot of software skills, because how we are moving towards is a lot of programming and software and simulation, etc. But then doing design and analysis is not going to change, right? Like you still have to design all these amazing aircraft of the future. So all the technical skills like software programming, design and stuff, that's something that you have to have for sure, right? But I would also love to stress upon other important skills to develop for you to be great in your career and move in your career ladder pretty good, and even within your school and your college years as well. So of course, make sure that you have a thought process of continuous improvement, and not settle for what you have currently. There is always going to be opportunities for improvement, and companies will love to have people like that who always stress on improvement and making sure things are getting better. Interpersonal and leader skills. Are you a good person? Are you treating your fellow employees, your fellow friends, everyone around you? Are you treating them well? These are actually skills that every company looks out for, and all your performance reviews and promotions and everything are actually based on this, way more than your technical skills. So make sure that you be respectful, act with integrity, and have those leadership and interpersonal skills to grow really well in your life. And to be problem solving, you have to think analytical way and think big picture rather than compartmentalized, right? So having that holistic thinking is very important. And as and when you grow through leadership comes managerial skills. So even if you can get to do, I don't know whether you're class leaders or there are projects that you become leader of and you manage a team, anything that you do, or even time management, for example, all of these skills put together are the skills for the future. And make sure that you guys think upon not just technical skills, but all the other skills put together, which any company out there will look for if you want to go big in any company. So those are the skills needed, Ratika, or guys.
Thank you so much for enlightening us with the skills that we can probably start working on from now onwards as students. Moving forward, over to you, Arjun.
Well, I think that's the completion of today's session, guys. I hope you guys liked the session. Why don't you start populating the chat box with how did you guys like the session today? And in the meantime, we had 3 sessions from Adhyaapan so far, the biology, chemistry, and physics sessions. We are planning 3 mathematics sessions as well, based on polynomials, probability and statistics, and coordinate geometry. All of these sessions will also be, of course, application based, a lot of career opportunities. How do you solve real life problems through mathematics, etc. We will soon release or let you guys know on what dates we are planning to offer these sessions. But from a time perspective, all of these sessions are again going to be conducted on Sundays at 10 o'clock, just like all our D2S sessions. So please keep, and I'll keep you guys updated on WhatsApp or on social media on when our mathematics sessions, will be delivered. And I would love for all of you guys to attend those mathematics sessions as well and enjoy it, hopefully, as much as you hopefully enjoyed all our science-based sessions. Next session.
Thank you, Arjun, for sharing that. I would love to thank each one of you for being such an amazing and participative audience. Varshini, we'll be letting you know the dates for math, so you'll get to know. about that. Not this Sunday, I think.
No,
But
it's probably going to be mid-May, but we'll let you guys know on when the math sessions will be.
before we leave, can we just have a quick checkpoints of how the session went before you leave? And please do fill the feedback form as well, given to you on the chat. So
Yep.
quick, maybe few words or in a word, if you can probably say, that will really help us to stay motivated and be on the task that we really love doing.
Yep. And Ratika, thank you to you for putting together all of this content and making sure it was a wonderful session like today. Guys, I apologize for the session going way more than our planned 1.5 hour session time frame. So apologies for that, but thank you guys for sticking on to the session and making sure that you guys learn more about the aerospace engineering industry. If maybe there's so much more to share about the industry, and I love to talk, like you can see, about the industry. So maybe if you guys want, and if you guys can request an aerospace engineering session, I can do a separate session on everything there is to know about the industry, and maybe that can be one of the Adhyaapan sessions. If you guys want such a session, you guys can request it on the WhatsApp community or email us at info@adhyaapan.org, and I'll be more than happy to talk for the next 2 hours about the industry and all the job opportunities. So thank you guys for attending the session. Thank you guys for attending this late. Like Ratika was mentioning, any words for feedback for us will help motivate us. So please fill out the feedback form and let us know how all of these sessions went. Thank you guys. See you guys in the upcoming mathematics sessions.
Thank you, Varshini, Ashi, Sohail, for sharing that. Bye, Dhanusha. Thank you. Bye, Mahimna.